Hello everyone and welcome to Recurrent Neural Networks video on Intellipaat. Do you know friends that traditional feed-forward networks cannot be used for learning and prediction with the sequential or time series data? To predict future ideas or values, a means for storing prior data is needed. Recurrent neural networks, often known as RNNs, are an adaptation of traditional feed-forward artificial neural networks. So now, before we discuss our today's agenda, do not forget to hit the subscribe button and click the bell icon. So first, we will discuss about what is RNN. Moving ahead, we will learn about how does an RNN works. Then we will learn about training an RNN networks. Moving ahead, we are going to discuss about types of RNN. Then we are going to learn about advantages of using a recurrent neural network. And at the end, we are going to conclude our session with discussing the limitation of RNN. So let's start with what is RNN. A unique kind of artificial neural network is called recurrent neural network, which is designed to cope up with the time series data or the data that contains sequences. Standard feed-forward neural networks are only suitable for independent data points. To include the dependencies between these data points, we must change the neural network if the data are organized in a sequence, where each data point depends on the one before it. RNNs have the idea of memory, which enables them to save the data and the states or details of prior inputs in order to produce the subsequent output in the sequence. So, as you can see in this diagram, there is a straightforward RNN which has a feedback loop. And to create the second network in this picture, the feedback loop is seen in a gray rectangle can be unrolled in 3 times step. Of course, the design can be changed that so the network rolls for the forward time steps. So here are certain terminologies that are related such as XT, HT. I'm going to tell you all about them. If I refer to as X in relationship with R, it is basically referred to as the input at time t. To keep things simple, we assume that xt is a scalar value with a single feature. You can extend this idea to a d-dimensional feature vector. Next is we have yt belongs to R, means y the output in relation to the required input or the set of domains of input. We can produce multiple outputs in a network, but for this example, we may assume that there is only one input. Then we have ht for Rm, means there are mth number of values in the relational domain, and we have the ht vector, which stores the values of hidden unit or states at a time. This is also called as the current context m, where m is a hidden unit and h0 is a vector initialized to 0. Then we have the weights, which are associated with the inputs in the recurrent layer. Then we have the WH, which is basically are the weight associated with the hidden units in the recurrent layer. Then we have the WY. This terminology means that there are weights which are associated with the hidden units to the output units. Then we have BH, which is belonging to relational domain R. It refers to as the bias associated with the recurrent layer. Then we have the BY, which is basically bias associated with the feed-forward layer. We can unfold a network for the time steps at each time step k plus 1 to obtain the given output. The unfolded network and the feed-forward neural network are quite similar. An operation is visible in the unfold network's rectangle. As an illustration, consider these activation functions. So, if I talk about the activation function, these are the following activation functions. The first one is the sigmoid function, which starts from minus infinity and goes on to a stable value of 1. Then we have the tanh function, which range lies from minus 1 to 1. Then we have the RLU function, which is straight line like y equals to mx. And at certain cases, we have the leaky RLU. So these are our activation function and you can choose any one of them. As a result, in the RNN's feed-forward pass, the network calculates the hidden units and values as well as the output after the time steps. The network's related weights are shared through time. There are two sets of weight for each recurrent layer, one for the input and other for the hidden unit. Similarly to an ordinary layer in the conventional feed-forward network, the final feed-forward layer computes the final output for the kth time step. Now let's learn about how does an RNN network works. So there is an input layer X which takes within the input to the neural network and passes it onto the center layer. The middle layer H can encompass multiple hidden layers, each with its own activation functions and weights and biases. If you have got a neural network where the assorted parameters of various hidden layers aren't tormented by the previous layer, the neural network doesn't have the memory. Then you will be able to use a recurrent neural network. The recurrent neural network will standardize the various activation functions and weights and biases in order that each hidden layer has the identical parameters. Then rather than creating multiple hidden layers, it will create one and loop over it as it needed. Now let's learn about how we can train a recurring neural network. So the unfolding in time to train the weights of the network is incorporated into the backpropagation method of an artificial neural network. Backpropagation in time or BPT algorithm for short is a name for the algorithm which is based on calculating the gradient vector. So you can see the training pseudocode all present all over here. The user has the option of choosing the value for training. It is the goal of the value at a time step t in the pseudocode below. Now first what you will do, set all h equals to 0 where h is a parameter as I have told you earlier. Then you have to repeat for t equals to 0 to n minus k and then forward propagate the network over the unfolded network for k time steps to compute all h and y. Then what you have to do is you have to compute the error as e equals to yt plus k minus pt plus k, where t is considered a time. Now finally you have to backpropagate the error across the unfolded network and update the weights. I hope so. This is a pseudocode for training a neural network algorithm. It's clear to you based on the parameters what you have to do. Once you implement this pseudocode on your project, then it will be very fine and easily understandable or how this pseudocode or algorithm works. Now let's discuss the type of RNN. Recurrent neural networks come in four different varieties, and the first one is one-to-one. The one-to-one RNNs are the most basic RNN types because they only support a single input and output. It operates like a conventional neural network and has set input and output sizes. Image classification contains one-to-one application. Then comes one-to-many. It is a form of RNN known as one-to-many which produces several outputs from single input. It accepts a fixed input size and outputs a series of data. Applications for it can be also found in image captioning and music. Then we have many-to-one. In many-to-one RNN, when a single output from numerous input units or series of them is required, many-to-one is utilized. For a fixed output to be displayed, a series of inputs are required. A typical illustration of this kind of recurrent neural network, you can see it in sentimental analysis. And finally, we have many-to-many. It is a sequence of output data which is produced from a succession of input units using the many-to-one method. So you can consider this as many-to-many relation, as simple that you have studied in the functions of calculus. Now, you would also be surprised to know that there are two subcategories for this kind of RNN, which is many-to-many. And the first one is equal unit size. In this instance, there are same amounts of input and output units. Name entity recognition is a typical application. Then we have unequal unit size. In this instance, the number of units for the inputs and outputs are different. Its use in machine translation is evident. Now we will discuss the advantages of the recurrent neural network. So the advantages of RNN are as follows. First, it processes the sequential data. Then it can memorize and store previous result. The third one is that it takes into account both the current and the previous result in the computation of new results. The fourth one is that regardless of increasing size of the input, the model size remains fixed. And finally, it shares weight to other units across time. Now, we will discuss few of the limitations of RNN. The first limitation which we are going to discuss is the vanishing gradient issue. Modeling time-dependent and sequential data issues such as stock market prediction, artificial intelligence, and text production is possible with the recurrent neural networks. RNN, however, is challenging to train because of the gradient issue. The issue of vanishing gradients affects the RNNs. The RNN uses gradients to carry information, and when the gradient shrinks too much, the parameter changes become trivial. Long data sequence training becomes challenging as a result. The next problem is exploding gradients. It is frequently referred to as exploding gradient when the scope of neural network during training tends to rise exponentially rather than decrease. Large error gradients that build up during the training result in very large modification to the weights of the neural network model cause this issue. Now there are certain solutions which you can apply to these limitations. And the first method is the backpropagation through time. When we use a backpropagation algorithm on the recurrent neural network using statistical data as its input, the backpropagation across time occurs. One input is supplied to the network at a time in a conventional RNN and output is produced. However, with the backpropagation, you also use this because the earlier inputs are used as an input. One of them is frequently referred to as a time step, and one time steps will have numerous statistical data points entering the RNN concurrently. The output from the neural network is used to compute and collect the mistakes after it has trained on a time set and provided you with an output. The network is then duplicated and weights are updated and recalculated while taking the errors into the consideration. The next solution is you can apply LSTM, which stands for long short term memory, in which the input gate determines how much of this unit is brought into the current state. The tanh function assigns weight to the values that might be handed to the based on their priority level, which changes from -1 to at least 1, which I have shown you in the graph, where the sigmoid function determines the values to permit through 0 and 1. The output gate determines which portion of the current cell goes to the output, and the tanh characteristics lends weight to the values that can be surpassed, determining the degree of importance ranging from -1 to at least 1, and enlarged with sigmoid output, while the sigmoid characteristics determines which values to permit via 0, 1. Now, I want to also tell you how does the LSTM network works. So, basically, the long short-term memory may be capable of training long-term dependencies and by default retraining the knowledge of extended periods of time. The three stages of LSTM network are as follows. The first one is that the network determines what to remember and what to forget in the step 1. And in the step 2, selected cell state values are updated. And finally, in the third step, the network determines which components of the state are sent to the output. So as you can see how LSTM can be applied as a solution to our required problems. That was all for today's session. I hope so you enjoyed our video on RNN neural networks.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective as it is taught by IIT professors and industry experts.